Thanks, Mark, for a great introduction. I want to, adjust the microphone a little bit so make sure you guys can hear me. Is it okay? Is the volume okay? Do I need to speak up? Okay, cool. If ever I had a habit of like going down a little bit after a few minutes, so remind me, just like this, I'll, be encouraged and then also move my volume up a little bit. So let me switch the laptop mode. All right. Well, this is the easiest setting I've ever had. Like usually have 15 minutes of tech stuff, like 5 seconds. It's great. So yeah, I have 3 sections today to show you. First is just the introduction of myself, and then show you a couple of slides showing you the organizational structure at Children's and UC. So you probably get some feeling, the difference and the similarities between these 2 institutions. I mean, between CHOP and the Children's. And then the second part is workflow analyses, which largely included in my thesis. And then you can see I will mention Kai's name a lot and his picture a lot on this slide, so bear with me. And then visual analytics as the third part, which is a new research line I added to myself when I moved to Cincinnati. So I'll show you some progress over there. This talk is intended to be interactive, so feel free to stop me. I will have a good chunk of time between those 2 big topics and then allow for some questions. So this is my trajectory. As Mark already said, all information, and I have some practical experience either as a data analyst or as a software developer. Throughout the timeline of those 3 things, you can see, one thing I want to highlight is the work as a one-person IT in the Congenital Heart Center at UMich, the Ma Children's Hospital. That was an amazing experience because they have their own research IT and an IS, and I'm a single person sitting in the peds cardiology doing all the clarity, extraction, and then build a system for them. So that's how I learned myself, and then feel like, oh, okay, I'm good at doing this type of thing, and also I align well, the research mission well with the operations, and then managed to publish something which I'll show you. And then I've been in Cincinnati after my PhD for 2.5, 3 years. So a very high level, 30,000 feet, is this, how I explain my research. So top left, it's got to be problem driven, okay? I always have a clinician collaborator and always working on a question that they think that they're critical. Either fall into one of the 3 buckets, which is the mission of the academic centers. From the bottom, the data, briefly speaking, can be either structured or unstructured. By structured data, I mean, those can be stored in a relational database, right? Can be queried. Unstructured are the nodes. I do have work on both sides. And the middle tier is the data analytics part. I'm not a machine learning expert. I know some low-hanging fruit stuff. Definitely not AI trained. I hope my K can be an AI stuff. And moving up, because that's a buzzword, right? So if you don't have that, then it's hard to get grant, I guess. Move up is the new thing I added, and then I would like to show you my interest in this usability. If you see the whole pipeline is like, how do you manipulate the information, manage it, and then analyze it, and then convey the information to the audience, and then that can help them solve the problem. So you can see clinical decision support will fit into this scenario. Some buzzwords. I'm going to talk about workflow analysis, bottom left, mostly methodologically focused, and then the visual analytics at the top. I do have a strong connection in the UC Design School, which is one of the top schools in the nation. I'm not going to talk about unstructured data, which I do have some studies in the readability area and information retrieval. So if you're interested in that area of work, feel free, send me an email. We can talk more. That's my belief to connect all 3 things together, and it's maize and blue. So this is the two studies I managed to publish in peds cardiology while I was working there as a PhD student. So you can see one is more, basically they don't have strong IT support. I developed a solution for them as a flexible, accessible, extensible platform, connect to EHR at the time, and then help them to do the QI and then all research stuff. So there are two papers published. One is in the medical journal, and then the other is in the AMIA Joint Summit, talking about the technical structure. So that gives you a sense. This is how I usually work with people, and then have one, in the clinical domain they publish, and have one more on the informatics side. And this is the structure. It took me, I wouldn't say years, because only 2 years working there, probably months to figure out the structure over here. So UC, University of Cincinnati, Cincinnati Children's, the VA, and then the UC Health. UC Health is like, Penn Medicine over here. And this is before the Department of Biomedical Informatics created. So it's before 2014. So usually how it works is, they're all separate entities. They're connected with each other by the CTSA award. All the divisions in the Children's Hospital, they are, through the research foundation, the faculty members have appointment in College of Medicine, Department of Pediatrics. And that department is empty from a UC perspective. It's basically managed by Children's Hospital. And there's no money flow between this, so there's no borderline case where you're a children people, but you pay by UC. They're all, you can cover by that, but you have invoice between. So if you are a UC person on the grant, you're a UC person. If you're a children person on the grant, you're a children person. It's more for children people to have the academic appointment and then give grants. Things changed when this guy came. Okay, many of you guys know this guy, Pete White. Now is my boss. When he came, you can see there's a department of College of Medicine created over here, and that largely synergized the effort between the university and the Children's Hospital. At least, the practical barrier is still there, but at least I think it's easier to cross those two boundaries from my perspective, because I'm working I'm based off UC. I'm a UC person. Everything comes from UC, but I do have the opportunities to work with children, faculty members, and then work on their projects, and then use this model to solve a lot of logistic problems. For your reference. Okay, so I'm gonna jump to the workflow analysis, and then there are many studies I want to show, so I will go with a quicker pace and then more at the surface level. Let me see. So we have this. Okay. But I do talk 1 or 2 studies that's MOC related. So pay attention if you need that credit. By no means this is the official definition, but for me it's all about efficiency. So the workflow analysis, the output of it is to identify the bottlenecks, right? And then for me, largely it's to improve the efficiency. If you can design something to improve efficiency and further improve quality, there are 4 methods that I'm using or working on right now. And then the first one is dramatically philosophically different from the rest because it's self-reported, right? So basically you ask people, what do you do in clinics? They'll tell you something they really do, either they really do or they see on the book, or they thought what things should have happened. So those may not be reliable, but still, if you're an outsider, get a good sense of what they feel, what they think about the workflow. And the second one, time motion studies, probably sort of the gold standard, quote unquote, borrow from business analysis fields. I'll show you my studies in each. And then recently, my interest moved more toward automatic collection of behavioral data, so we don't have to send a lot of people to the field to understand that process, and then can scale up. So, these are just some simple examples. I'm working on the social worker project, talking about, they move around in clinics a lot as a result of the interview. And then also there's a significant delay in the endoscopy procedure rooms for the nurses because notoriously doctors don't show up on time. And then also how to use PGD, HDs in psychiatry department. So those are things I ask my students to do, and then they can produce. They're trained and they can produce reasonable results, and I pair that with other methods. I'm very interested in use the academic workforce. So I partner with the design students. They have like 16 students come in, so I split them into 4 groups, and each of them interview a group of people for registry, and then eventually get 4 abstract published. So that's one way to increase your publication, I guess. But all of that is I don't have a. I think this is a later picture. It's not that clear, but bear with me. So all this starts from my participation as a PhD student in Kai's ARC grant. This is one of the few studies I'm going to show in my PhD years. Many of them are in Cincinnati afterwards. But just give you a sense, what we did at the time was a mixed method study. There's a EHR intervention, a new CPOE system, for example. And then we do a pre and post study. Before that, it's ethnographic study, time motion studies. Afterwards, we do the same thing with also the interviews, and we do triangulation and member checking to have an understanding how the workflow was redesigned to accommodate that or improved in that sense. But from a methodology perspective, Kai and I developed a iPad application. They're all configurable. If you have a list of things you want to observe, people you want to observe, who's going to do the work, put it in, and you have an iPad application, a generic one that you can use. It's not depending on the Wi-Fi, because we know Wi-Fi may not be stable in the clinical area. So they can use this to do their shadow work. On top of it, it's a visual analytics platform with some stats, to see which bucket has more significant change before and after. And then here's something I want to show you. Why we need the visualization piece. I'm gonna mute I'm gonna talk through it. So basically, let me see. So this is the based on the time motion data, I develop an application, right? So technically, it's not that complicated. It's an image on the background for the floor plan, and then the data from a time motion. When time flies, you see, before and after, what are the hotspots. The bigger the node is, the more people stayed over there throughout the day on average. So we need this type of thing because in statistics, they may not be significant, but we see some clinical significance in terms of hotspot change from the interview and observations. And it's hard to justify from a quantitative data, so we visualize it. And to show that, these are the things that people, really think will change their practice in clinics. So that's one example to use the time motion studies in a visualization way. And so we got software disclosure. I think there's a limited commercialization opportunities, but definitely a good weapon for me to collaborate. So if you have any, workflow analysis projects, happy to talk and then set up something over here. Actually, I have 2 studies already finished using this tool. And then also work with Kai and other, folks in AMIA who are, experts in the area. We have a book I think it just published on this matter, and I contribute one chapter in terms of time motion studies. So we listed we sampled 3 time motion tools, including the one I show you. So talking about 2 studies. So this one is with the Crolotto folks in ED. So it's not a pre and post study. It's just in ED that they want to develop a decision support tool on something. And the first thing, I'm glad that Mustafa has that sense, like workflow is the first thing to understand. So we work together, basically use interviews and time motion studies to understand their decision points, right? Understand different patterns of the clinical flow by different clinical roles. So just show you a little bit more detail about this. These are if you're interested in looking at the paper, but these are the different decision points summarized from the qualitative data. These are the frequent patterns in terms of sequential pattern mining, and then we summarize them based on the clinical role. So you can see, attendings tend to talk to coworkers when they jump into the process and then do the entry at the end. NP and PAs more likely to sanitize their hands. I'm not sure if it's a common thing, but it's an interesting comparing to physicians. And then residents, they talk to patients and likely they will check with their attendings before they leave. So these are good contextual information to make some decisions. So, well, in a very abstract level, basically you need to consider in that particular setting, the clinical roles, the location of the decision, and then also different point of care. It may not be that surprising, but that's based on our understanding and then the work in the field. And then Mustafa and his team is developing that clinical decision support tool in that particular environment. So the second study that also published using the tool I presented is in Switzerland. So they have a mobile application at the bedside. So the idea was, if you have the application, the nurse can get information or enter information in it. They would have less time interact with EHR at the bedside, and hopefully that translates into more time with patient at the bedside. So there's a preliminary study that we talk about the setting and then use the time motion studies to support that. The problem of time motion studies, which I'm actually not a fan of, is it's very costly, right? You have to manage that. And then you can only send certain people in the field. Like if you imagine send 100 people in the field, then the workflow you observe is not a workflow anyways. So I'm more interested in using these automatic logs to infer the behavior, although it's noisy, like all the big data stuff. And it's hard to interpret, because if you see some records, you don't really, it's hard for analysts to map that with the actual clinical behavior. Even with physicians, they have to recall their behaviors or do some matching between the actual behavior and the log. And the log is largely depending on the granularity of the log is largely depending on the vendors, right? So Epic's way of logging could be different from Cerner. So we have a feasibility study in AMIA and talk about, in that parent study, the ARC study, if you remember, we do have the log data. So what we're trying to understand is we know the workflow redesign based on multiple data sources, including time motions and observations. What if we hide that? We just get the log and how much we can uncover just based on the log. And I mean, it's not surprising for you to, for you that the result is like the log itself is noisy. It's best to pair with other data source to complement each other, not just use the log itself. So all this is very related to operations research. So I'm also work with B School faculty members. So we have a simulation study in the handoff, focusing on the dashboard in medical errors. So very simple. I want to highlight this just because the publication process is super long in this field. It's like, I don't know, 2 years from submission to get published. Mine is a special issue, so it's quicker. It's like 1 year, but it's very surprising for the B School faculty that this can be out in a short period of time. But in short, basically we have a simulation study, and then we have 30 people used a mock-up EHR, and with the intervention of a phone call. And we focus on the use case of dashboard, which serves both a information hub, because people can use the dashboard to go to different pieces of the charts, and not just the information hub, but also a summary of information that can quickly consume, what happened to the patient. So that dual role make the dashboard very important. And then we, in the discussion, we thought it would be helpful to have something like a situation-aware or context-aware dashboard. So the dashboard knows, in a smart way that what you're looking for right now, and then what critical thing patient right now, and then they can maybe better serve the purpose of handoff. This is another side project for me to use the logs for education purposes. Many of you know Dan Schumacher on the side is ED doc in children's, but he's doing his PhD in medical education. So the purpose of this paper is basically twofold. We have residents, we have patients, we have resident scores, we have patient outcomes. We try to say whether the best performed residents would really have the best outcome, patient with best outcomes. But the problem is in the middle. We don't really know who are the primary residents given a day, given the patient. There's no way, at least in children's, there's no way in EHR, the single place, say that. So what we did was to train a model, basically. We have some human observations for 3 weeks. 3 attendings help us to say, for this given day, for this patient, this is the resident. And then we include the notes, the orders, who write the progress notes, who write the orders, and then the event logs, those sorts of things, and create a decision tree, achieve reasonable performance. So from that, then we can have a bigger picture to link them together to answer the bigger question. So one problem of event logs is, you don't really know what happened in between, right? Because you only get the events in the EHR. So what if you have a 5-minute gap, right? Does it really mean a gap, or does it mean somebody stand up and get a coffee, or what? So can we pair that with the location tracking information so we know more contextual information, like what happened during that gaps? So that's the fourth method I'm working on. And then the idea is definitely not just use location tracking its own, but also pair it with EHR logs. And these are the people I'm working on. Steve is the main driver of this, and then Lindsay and then Kevin are the key persons I'm working with. So we show, I think in just a few weeks ago in Chicago, there's a Children's Hospital in Analytics conference. That's the first year, and then we show the results of this study in the sedation process in ED. So basically, we when the patient comes in with a painful fracture, for example, you start the sedation process, right? And a normal process, I don't know if it's the same here, but in children's is 180 minutes. If it's 180 minutes, that's okay. If it's over, that's something problematic. And we need to give them ketamine, right? So from patient arrival to ketamine given has to be within 80 minutes. So the question here is, can we use the timestamps, both from EHR and RTOS, for these two groups? One is within 180 minutes, one is above 180 minutes, and then see, which category they spend more time, right? And then try to identify the root cause of the delay. So this is the clinical map from the expert. We try to simplify it, map with the timestamps we get into 9 steps in 4 events. Okay, patient arrival to put in the sedation room, for example, and then for sedation doc, for standing eval to they enter the room, so on and so forth. And then by modifying the tool, the time motion tool, we'll be able to quickly generate the stats, right? The red ones are the p-value that's significant. Basically, for each bucket, we can compare the normal and the long cases, and then see how much the improvement or the increase or decrease that will be, and whether that's significant or not. There's a visualization attached to this to help you understand. So you can see everything is a bit longer, so that's not too surprising. So everyone contributes to it a little bit. But the sedation doc seems to be the bottleneck because the light blue bar is much longer afterwards. So that's the area that they can work a little bit more, and then we might look into that behavior a little bit more. So I'm developing, hopefully hopefully I will accumulate enough use cases, and then show that can we have reasonable results just by doing interviews and the logs and maybe location tracking to reflect a reasonable amount of workflow behaviors to answer the questions. I showed you the social worker and endoscopy project, and then definitely seeking collaborations. So that's another big chunk of research I'm doing right now. Again, this is added, so not part of my thesis, although it was touched a little bit in the workflow analysis, but got it into this, very interesting. So a lot of that is like self-learning through the participation in AMIA work group, and in particular the visualization working group that's formed in 2015. And before that, there was, the working group was resided in the IEEE area, and then a couple of people, go both places. So we have now a workshop called VHC that's alternating between IEEE and AMIA. This year will be in Vancouver in October. The submission just ended, but if you definitely feel free to join. And then next year we'll bring it back to AMIA. So I participated in that, and especially a task force on evaluation, because I'm interested in evaluation piece, and I think that would be a good angle for me to jump in the visual analytics area. So, and that was a beast. It's like 3 years of collaboration with 16 people across the country, and then with monthly, calls. And then, but it turned out to be good because we have a JMIA systematic review published, and then that surveys the literature, and then have some suggestions, recommendations, which I'll show you. If you want to do evaluations on visual analytics stuff, what strategies or what aspects you want to consider. This is just a Prisma flow. We have 200 papers, all are like reviewed by 2 of the 16 people with that assignment, achieve reasonable CAPA. At the end, we have 78 papers to summarize. So really the meat is these 4 things. One is to use commonly reported metrics. It's obvious that if you use different sets, then the results are not that comparable. Although there's no given list right now for you to pick and choose, so that may be a follow-up work on this. Vary the experimental design by context, right? So, for example, are you doing a pre and post comparison for visual analytics, or you are just developing something that does not exist? That experiment could be different, right? And increased focus from the paper we saw is interaction and workflow. I'm like, yes, this is something I can jump in. Very good. And then lastly is the adoption of phased evaluation strategy. So that phased evaluation is also critical, because if you just do it once, because people are using the visualization, the expectation might change, right? So if usually I think there are at least 3 times. So if you do it in the lab first, make sure usability is high, and then you deploy in the field, do the initial testing, and then maybe a few months later you do a third one. So I think that's what we mean by a phased evaluation. So we did all that, and then I think it set a good cornerstone for me to keep working on the visual analytics stuff. Then I'm going to introduce another project that is a collaboration with the Children's Hospital by Andy Spooner. I think some of you know. Andy is a CML over there. He's very, very interested in this work, and definitely he came up with the name, not me. I'm not that talented with the acronym. And then unfortunately we cannot put the acronym in all the meetings, because people will say like, we meeting in this room, and we'll get into trouble. So the ultimate goal is the clinical decision support. Can we have a reliable decision support tool, CDS tool, that can detect weight errors and prevent weight dosing errors. And then the first step definitely is to the machine learning piece, right? To how do you train an algorithm that can at least do that? And then we can consider the human piece around it. So let me dive into it and tell you a little bit more about that. So this is a growth chart, right? So either you're a patient or clinicians, you're familiar with this type of setting of the data. In pediatrics, we exclude on purpose 0 to 2, just because that range, the data on that range is complicated, sensitive to different things. So we only look at 2 and above. And the weights is like, 0 to 100-ish. So if there's an error like this, you can spot it, right? But you cannot do it for all things. And even there's a check during clinics, you still see something like this. And this is the page for the dosing, right? So you can see maybe the obvious error could be a kilogram and a pound transformation, right? It can be easily overdosed if you put the wrong unit over there. But really, in the paper, error, it's like, in the paper error, it's like if you get something like this, you ignore it, right? Just, you don't care about that. But you cannot do it in electronic error. So what we're gonna do, as I said, it's probably not practical for physicians to check all the growth chart every time they see the patients, right? So can we use the machine to help us? And then maybe Epic has some solutions, but I guess, all of you have experience, like, if you see something like this, it's not reliable, then you probably move the mouse to no before it shows up, and then just click it, right? So alert fatigue is a common thing. And we definitely need to work on that, but what do you mean by an error, right? So if you see this, I think, maybe I ask the audience, what do you think, given this chart, which one might be an error, or most likely to be an error? I see some hands, maybe the second point, bottom right, that little corner, a little bit off the trend, right? So maybe this one could potentially be an error. But, you can easily spot that. But if you run a regression line, definitely, I don't know, how do you tell machines to spot which one is an error? There could be more sophisticated, programs to do that, but it's not obvious. So, and there are other situations, these things like this. What do you want to do? So, I guess to summarize, I think from that sort of review it's easier for human beings to detect that errors, and then but it's time consuming, and the alerts right now is rudimentary, so we can design better. Machine learning or even AI, which is a buzzword I'm not so familiar with, could be good partner with the CDS. But the very first step is understand, what are the characteristics of those abnormal values, so we can, target more reliable features to develop the algorithms. And then this is all discussed in AMIA last year. We want to introduce an idea of clinical importance of these errors, because we thought it's not, we will argue that it's not the true, whether the point is a true error or not. It's more about whether the clinicians need attention when they prescribe something. Even if it's an error, if it's just off a little bit, it doesn't matter, right? It won't affect the dosing. But if it's not an error but it's off a lot, then you probably need to check and make sure it is the right weight. So we introduced that idea and then think, okay, the whole algorithm training process then has to be supervised, right? Because there's the human notion behind this in terms of the clinical importance. So we have two questions here. One is, there are existing algorithms, including one developed here in CHOP in 2007, probably in 2017 by Bob, sorry, got his name wrong. And then we compare his method with ours and the CDC method and see, how good we are in terms of detecting the clinical importance errors. The second question is, what are the charts that cannot be captured by any of the three? What are their characteristics? Can we, have features better to reflect those characteristics? So this is the data I got from children's, all de-identified. We got all the weights. There are a few words, but it's a tremendous effort to get all the weights and then solve all the problems. Andy helped with that, and through the discussion, it's amazed how much effort that needs to pull that and clean that. And then we have experts to annotate that for us, and definitely need to achieve good agreement. So we have 4,000 patients as a test case, all age 2 and above. And then we just have people highlight the notes. We develop application behind this. Highlight the note, say, if this is an error, potential error, the orange. If it's a significant error, then that's red, if just by clicking the note twice. And then, 2 people read it independently, and then resolved by the third expert, which is Andy, if there's any discrepancy. And then we report 2 different kappa, because there's an adjusted kappa for a data set that has, very skewed. In this case, it's very skewed because only 0.5% of the weight values are potentially erroneous. But you can see the next problem we run into is, well, the annotation sounds cool, but it's very tedious, right? So imagine you sit down in the computer flipping through the charts, and it will take a big chunk of time. So what we end up with is shift the gear a little bit, focus on the development of a tool that can help you do the annotation faster by using 2 principles. One is the grid size. If we place a grid, a bunch of growth charts on the screen once, as a human being, it's easier for you to spot, right? Something problematic, right? And the second principle is the annotation style. Somebody would love to highlight, when they see this page, highlight potentially problematic graph, and then go into each one and annotate the notes. Some people might prefer just click one by one and finish one by one. So we have these 2 different settings, either the grid size, whether it's 3 by 3, 5 by 5, 10 by 10, that can be adjusted, or the annotation style, whether it's 1 step or multiple steps. So we developed a tool in our Shiny using this, and then I'll show you some evaluation results, usability testing results of that particular tool. We call it VAT. But really, for this initial study, is to collect the reference standard, right? So what are the clinical important abnormal weight values? And then we essentially want to do something like this. So there are 3 methods. There are some measures. We have the reference standard, right? Call it reference because we didn't do a chart review, so it's not a gold standard. Reference standard, and then we want to see the performance of the algorithms, and then Charles methods is one of them. So basically, the results show that we have reasonable kappa. We annotate 4,000 record patient charts, about 50,000 points. So it's a good reference standard. And then this is the performance of the algorithm. There are some parameters in each algorithm. So for example, CDC N4P7 means, it's -4 to +7 in their algorithm you can tweak. CHOP as well, the default value is 1.5 based on the data, and then there are some ways to tweak the weight of the Z-score. We just experimented with different settings. And well, CHOP is the best, right? So they all achieve high specificity, but it's not surprising because most of them are negative, right? 99.5% are negative. But CHOP get the best recall, it's close to 20%, but it's still not enough. If you want to build a decision support based on this, I guarantee you, one day later, it's going to be alert fatigue. So definitely a room to work on this. And then we looked at, let me see, there are 163 charts out of 4,000. That's errors not captured by any of the 3. So we look them and then have domain experts, summarize the reasons for us. Basically, simply speaking, there are three types. One is kind of a minor change. As a number one shows, it's an obvious error, but everyone else lines up well, but it's not going to capture by the algorithm because it looks at the points before and after, before mostly. So, and then the second part is the missing data, which is definitely a problem to take care of, and then some borderline cases. So it's a continued investigation, get some little funds to support this, and as I said, we're specifically interested in having this tool set up that may be used for other cases, but as long as the time series data, you want to annotate something, this tool can be used. The goal is to annotate 15,000 charts for algorithm development, and then also extend the pipeline to the patients under 2 years old, which is just submitted as a RO3 on Monday. So in MedInfo in November, if you're going, you'll hear my student presenting this. So how do we develop that VAT? Basically, it's a phased development. Phase one, experts, sit down with the expert, do some co-design process, and then phase two, some iterative refinement with a group discussion, and then phase three to experiment and have preliminary user testing with the potential users. So this is the application. To show you, it's an R-Shiny application. It's definitely limited in some ways, but it's good for people who know R and then want to develop web applications. It's fairly quick. So if you click, for example, the chart below, then it will pop up with the details, and then the user can annotate each node. By default, they're all normal, and then you can click by the number you clicked, the color will change. Based on the number of clicks. And then you can see this is a 5-to-5 grid, but you can change to 3x3 or 10x10. And that's part of our experiment, the user testing. So, and then this just shows you some, summarized usability problems after the first phase. But the experts definitely think it's great, but there's some, teeny things that you need the actual users to use it. And then we have the 5 participants as a preliminary user testing on this. Each of them annotate 450 charts. Seems that there's a learning curve because the first set, it can be, if you annotate 25 charts, it takes about 8 minutes, and the second time you do it is about 6 minutes, so it's much less. So that will give us enough understanding, if we want to annotate 15,000, then how many reviewer annotators I have to hire, and then how many data sets I have to send to them with a good SUS score. So the system usability score is a standard survey. So this year in AMIA, fortunately we got 2 podium presentations in, and then one of them talked about the formal evaluation. And then if you're there in November, happy to get your feedback on this. The one key thing we found was it doesn't really matter the expertise level of the annotators. Like if you get fellows versus medical students, the annotation results doesn't change that much. It's more about how many people look at the node. So so we in our follow-up study we try to have instead of 2, maybe have 3 or 5 people look at the node and do annotation for us. We also use all the 3 methods, automatic methods, as well as the human annotation to test the algorithm, to develop the annotation pipeline before we actually get the 15,000, and which was also a podium presentation. So just show you a little bit performance over here. So we have all different machine learning algorithms. RF stands for random forest, which is the highest. So that's why I highlighted. The test set is the 4,000. That's annotated by human experts. The 4 data sets annotated by the algorithms, the 3 algorithms we tested. And at least 2 of them have to agree that one is an error. So we use that as a reference standard to test the pipeline. So you can see we can actually achieve reasonable AUC, and it's actually pretty good. Although it's still preliminary. We were not sure if we can get the same performance after we get a 15,000 annotation, but we'll see. So with that, I think these are all everything I want to share today. I think there are enough time, 8 minutes, for questions. And I want to thank you for your attention, and then happy to answer questions. Thanks.